This is Akashvani. In the weekly program Current Affairs, now we bring you a discussion on various aspects of the Genome India Project. The participants are Dr. Suchita Ninave, Advisor in Department of Biotechnology, Ministry of Science and Technology, and Sagar Kulkarni, Journalist.
Prime Minister Narendra Modi launched the findings of the Genome India Project on Thursday. Scientists have made available whole genome sequencing of 10,000 Indians across 99 population groups. We have with us Dr. Suchita Ninave, Advisor, Department of Biotechnology, who was closely involved in the project, to share us the details about it. Tell us about the Genome India Project and how important is it for scientific research?
First of all, I thank you, Akashvani, to have me here and giving me this opportunity to talk about Genome India Project. And I'm very proud to be associated with this Genome India Project and setting up of IBDC since its conceptualization. And hence, yesterday's event wherein our Honorable Prime Minister had delivered a video address and our Honorable Minister released the feed protocols. It was very proud moment to all of us in Department of Biotechnology as well as for the whole country and our scientists and researchers, especially in the field of genomics. About Genome India Project, we initiated discussion on this project in 2019, and after detailed discussions among all domain experts and all other stakeholders, we sanctioned this project in the initial phase of 2020. That we sanctioned this project and thereafter, after these 5 years, we are here with the major outcome from this Genome India Project. The main objective of this project was to sequence 10,000 Indians from different populations. We have covered 99 major populations, and the whole set represents these 99 populations. We did sampling from 20,000 individuals. We have kept the bio samples of these individuals in the biobank, which is maintained in the nodal institute which steered this Genome India project in CBR. Out of these 20,000 samples, we have sequenced precisely 10,074 samples. In sampling, our 4 national institutes were involved. First one is CBR, which was a nodal institute. Then CCMB, NIBMG and IGIB. These 4 labs were involved in sequencing. Other DBT institutions like CDFT, they all were involved in sampling and other activities. Institutions like IITs, they were involved in analysis. And thus, the major 3 groups were there. Some activities were overlapping with the institutions, but major 3 activities were sampling, then sequencing, and then analysis of the whole genome, sequencing of all these individuals.
The Prime Minister yesterday said that the Genome India Project will help scientists understand the diverse genetic resources, and it will help understand the Indian genetic landscape.
इस प्रोजेक्ट की मदद से हम देश में एक डाइवर्स जेनेटिक रिसोर्स बनाने में सफल हुए हैं। इस प्रोजेक्ट के तहत देश में अलग अलग आबादियों से जुड़े 10,000 लोगों की जीनोम सीक्वेंसिंग की गई है। अब ये डेटा हमारे वैज्ञानिकों को, रिसर्चर्स को उपलब्ध होने जा रहा है। इससे हमारे स्कॉलर्स को, हमारे साइंटिस्ट को भारत का जेनेटिक लैंडस्केप समझने में बहुत बड़ी मदद मिलेगी। इन जानकारियों से देश के नीति निर्धारण और योजनाओं के निर्माण का काम भी आसान होगा।
Dr. Ninave, tell us how it will help in precision medicines or precision diagnostics.
Here I will say that in general it is said that about 1 in 1,000 positions differ between any two individuals on average. Thus each individual is different. There are many other initiatives going on and have been successfully completed also on whole genome sequencing. But we have noted that Indian population is not represented in their data sets to the extent which, as compared to our in proportion to our huge population of our country. Okay, and therefore our Genome India project is very important to our country, where we have sequenced data of our own people. In this Genome India project, when we have done this genome sequencing of 10,000 individuals, the main outcome after analysis of these sequences, we found that there are 135 million variations. The analytic groups, they have found it. Out of these variations, about 7 million variations are novel variants, which are not available in the global datasets. We can say at this stage, this is a big discovery for our country, and that is specific to our own population. These novel variants may be available in other population also, but at this stage they are not identified, and therefore it's a first hand information specific to our own population which has come out from this Genome India project.
So you mean to say the 7 million variations that have been identified will help understand our people better, maybe their diseases that contract in their lifetime, we will be able to identify that better. Is it right to say?
Yes, definitely. Because genetic makeup is different, as I said earlier, individual to individual it differs. Okay. In the same way, even within India, we can take the example, even our Honorable Pradhan Mantri ji, he mentioned yesterday in his address about sickle cell anemia, and our Prime Minister has launched a mission to deal with this problem, which is really a huge problem in Orissa state especially, I can say. We know the science behind the sickle cell anemia, why it is happening, how it is happening, which gene is responsible, and the other details. But it's not only the science limiting to the sickle cell anemia gene, but it's a peripheral environmental aspects also within our body itself, within our gene itself. The other factors are also responsible. So what is different in Orissa population? Why it is not occurring in different places? So this is, we can get such type of information when we do whole genome sequencing of individuals. And initially I said that we have around these 10,000 individuals. They represent 99 populations, and in our India we have distinct populations around 4,600. It's a huge country, huge population, and distinct varieties we have in different ways.
So 10,000 whole genome sequences, it must have required a huge space to store all this data. We have the Indian Biological Data Center in Faridabad. So is this data stored over there?
Yes, we have Indian Biological Data Center set up in Faridabad. It's a biocluster of Department of Biotechnology. There we have IBDC. I will go little back a few years. Initially, when Niti Aayog announced its AI policy, that time in Department of Biotechnology, we discussed various aspects of AI and data. That time, two major issues came up from the domain experts that to do AI type of technologies, to use these advanced technologies, we need the structured data sets to work on. And if we have structured data sets, we need the repository to put those data sets safely. And if we are putting the data sets, we need a policy to deal with the sharing and access to the researchers. On all these aspects, when we had the detailed discussions with domain experts and other stakeholders, we came out to work on some policy guidelines, and thus Department of Biotechnology has released Biotech Pride guidelines. Under Biotech Pride guidelines, we have discussed what are different biological data will be covered under these guidelines and how it should be shared, to whom it should be shared, what type of data should be placed in under which category. There are three different categories: open access, managed access, and no access, because some information is definitely sensitive to our country, which we have to kept it under no access category also. After Biotech Pride guidelines, we simultaneously worked on setting up of our own biological data center. So far, our Indian researchers are submitting the information on data sequences and other biological sequences information to NCCS or EBI type of data repositories. There we don't have any control over that information. But when we have our own data center, IBDC, there we have uploaded and archived this Genome India Project data, and it's along with NIC. All the safeguards have been tested, and now we have released the feed protocols, and those protocols give the details what information will be required when the researchers or any individual will seek the data from data center. And under managed access, especially this Genome India Project data will be kept under managed access, so that we can have all the details where the data will go and how it will be utilized, and all this information will be in the government's custody.
So researchers will have access to the findings, the whole genome sequences of the 10,000 individuals, so that they can work further and develop medicines or any other details or studies required on the Indian population.
Yes, definitely. And in yesterday's event, we have released call for proposals. And under call for proposals, we have mentioned various areas where Genome India data can be utilized. This data can be utilized to find out some biomarkers, to develop the genetic chips, to work on different drug development molecules, and many more studies, in fact. And the call for proposal gives all the details on that. We will seek the project proposals from our researchers from different fields, including obviously biotech fields and data scientists. And collaborative research projects will be funded under this call for proposal, wherein Genome India data will be accessible to researchers and we are expecting speedy progress in this field.
This whole genome sequencing opens up a whole new world as far as healthcare is concerned. So, as an individual, can I seek whole genome sequencing of myself so that I can know better which diseases I can contract in my future life?
Yes, it is possible, but so far under this Genome India project, we have done the genome sequencing of healthy populations, which are as per the information provided, they are healthy population. I can say yes, this is possible. Commercial companies are doing whole genome sequencing of individuals, and the data need to be analyzed further, keeping in view the data sets available globally in public domain. Yes, that is possible.
The Prime Minister mentioned yesterday that knowing genetic pattern will help identify suitable medical solutions for genetic and hereditary diseases. So could you explain how it will be done?
Yes, that's what I mentioned, like even sickle cell anemia or thalassemia. These are the hereditary disorders. A child gets heredity from mother or father, okay, as everybody knows it. And in especially for rare disorders like thalassemia or sickle cell anemia, treatment is a costly affair, and it's life-threatening also. Everybody knows it. Therefore, focus should be on prevention for such. And if we do the counseling and early checkups, or if we can go through the history of the families and other details, we can work on this aspect, and we can increase the prevention aspect for these diseases more and more. And that should be the strategy for genetic diseases, I can say. Instead of treatment, we should focus on prevention, and early detection during pregnancy will definitely be helpful in such rare disorders.
India is a 1.4 billion strong population, and we have 10,000 genome sequences. Are these enough, or is there need to do more?
As I earlier said, we have distinct populations around 4,600. In Genome India Project, we covered 99 populations. Obviously, it's a phase 1 project, and we could do that much. And under that project itself, we could have a sufficiently good knowledge about our Indian landscape. However, definitely we will be planning for expansion of this program. We can say Genome India phase 2. Now itself we have given call for proposal, wherein the present data will get analyzed for different aspects. But in Genome India phase 2, we will be focusing on some diseased populations, say rare disorders or neurological issues which are also genetically prevalent, and then lifestyle diseases like obesity or diabetics. Like that, we will be going ahead.
You also mentioned something about the UMID initiative of the Department of Biotechnology. Could you share some details?
Yes, there was a mention of UMID program. Department of Biotechnology has conceptualized this program. Much earlier, Department of Biotechnology had funded various genetic labs in the country. Through that experience and adding to various aspects to that, we have evolved this UMID program. UMID program has 3 major components. One is screening and counseling. The second one is training of the clinicians, because we do not have sufficient expertise in the field of genetics in the country, especially in hospitals. So we have focused that who are regular doctors in the government hospitals, we are training them. And under this, we have screened a lot of population, pregnant women and newborn children, and we got many number of positive cases where we have given some preventive measures or we have guided them for further course of actions on that. And this is the outcome so far, I can say, in the pilot phase of UMID, where we had only 4 Nidan Kendras. Nidan Kendras basically the infrastructure we are setting up in the government hospitals. And now we have expanded it throughout the country. And we have many more, around, I think if I remember correctly, around 25 Nidan Kendras all over the country. And under that, many aspirational districts are covered for screening. And this program is really expanding well. Under rare disorder policy of Government of India, issued through Ministry of Health, UMID is one of the major program under that policy. And we are planning of, I can say, that as a R&D based department, our Department of Biotechnology, we will create the whole foundation for a futuristic national screening in rare disorders for the country.
Right. Could you tell us about the costs involved in this huge project of sequencing 10,000 whole genome sequences?
Yes, Genome India Project is a collaborative network project of 20 institutions, and we invested rupees 237 crores in this project. It went for 5 years, and the outcome, as I mentioned earlier, we did 20,000 sampling, made the biobank of those samples, and 10,000 sequencing. We made the data uploaded on IBDC, and different variations, multiple variations we could find, and the Indian genome reference will be made on that, and it will come out very shortly.
Are there interests expressed by global players in accessing this data?
So far, we are in interacting with these two major data centers, NCBI and EBI. Mm-hmm. But at this stage, our feed protocols are ready only to share this data with our Indian researchers at this stage. But once we will gain some experience on data sharing, we will go ahead to develop the protocols, how to share this data with the commercial companies or with the global partners or the international scientists, international repositories. We will work on that in coming years.
Research and development is also picking up in India in a big way, and in this area itself, a lot of research is happening. And do you encourage these researchers to store their data or research outcomes with the IBDC that you have found?
Yes, definitely. In the funding agency, we have made it compulsory, mandatory to the researchers where the government is funding the projects. We have put under terms and conditions that they have to mandatorily deposit the data to IBDC. Yes, definitely. At this stage, there are some issues coming up, like for publication, the accession numbers given by IBDC are not being getting accepted by some of the publishers. We are working on that, and we are interacting with NCBI, EBI to become the member there, so that the India, if become the member of the international collaborating data center, that will help us in resolving all such minor issues which we are facing right now. And definitely, I will say yesterday's event will give the popularity to IBDC and will create a confidence in our researchers, and they will come up with their data sets to IBDC.
Initially, when medicines were being developed, we had European and American populations as a reference point. So, with this Genome India project, can we say India has become Atmanirbhar or self-reliant in this field?
In genomics research, definitely, because of this Genome India outcome in the health sector especially, we will progress, where I can say that we will be able to find out Indian solutions for Indians through Indian data. So this is our own project for our population's health, and hence it's definitely the government's in this Atmanirbhar Bharat mission. It will definitely contribute a lot.
So we expect major benefits in disease prevention and vaccinations as well.
Yes, disease prevention, diagnostics, and early cure. Definitely, we will progress very speedily based on this Genome India data.
Have Indian companies also shown interest in accessing this data?
Yes, they are showing, but as I said, field protocols prepared at this stage are for researchers, and Genome India data will be provided under managed access, where government will fund the projects, not only Department of Biotechnology, any funding, so that we need to gain the experience that we are going safely. Therefore, initially, we would like to give the data through the government funding only.
Dr. Ninave, Genome India pertains to human healthcare. What are the other areas which can benefit from genetics research?
Yes, the advancements in genomics research has far-reaching benefits in medical sciences and for human health, as we discussed so far. However, genomics is not only limiting to health sector, but it has impact and advantages in other fields of biosciences like agriculture, environment, or forensic sciences also. To give the examples, in agriculture, we have heard about golden rice. It has high content of beta carotene, which is a precursor of vitamin A. Then genomics also contributes to renewable energy solutions also. Our researchers are exploring the genomes of microorganisms capable of producing biofuels. We could be seeing revolutionary changes in the forensic science also. DNA profiling made possible through genomic techniques. We are aware about it.
Thank you for speaking to Akashvani.
Thank you very much.
You were listening to a discussion on various aspects of the Genome India project. The participants were Dr. Suchita Ninave, Advisor in Department of Biotechnology, Ministry of Science and Technology, and Sagar Kulkarni, Journalist. This program was produced and presented by the News Services Division of Akashvani.